density, a lot of the work is done up front in your CAD package, as we briefly discussed in the presentation. So you want to make sure you design the part to have internal cavities and cores that fit in those cavities but are offset by about 1/1000th of an inch. Once you've got the CAD work done, we can now bring the file into Insight. We'll start by opening the first file. Once the file has come in, we can orient it so that our reference feature is at the origin. I'm going to go to the STL Rotate menu. Then I can rotate my part to get it into the correct position. And once more in Z. Now I can go ahead and slice the part. And at this point, I can page through the layers, and you'll notice I have an internal cavity here. If I generate toolpaths, it fills in everywhere but leaves this internal cavity. If I go down, you'll notice that the part is solid. So for this first portion, I want everything to be solid. I can simply save this job as it is. So I'll go to File, Save As, Job, save it with the same name. Now at this point I can close this job and open the next one. Once I've got the internal cavities open, I'll want to rotate them to match the other one. So I'll use my reference feature once again. And now I can rotate into place. There we are. If I look from a front view, you'll notice that these cavities appear to be floating in midair. That's thanks to my reference feature. Now I'll need to slice the part. And at this point, if I were to page up through the layers and generate toolpaths, if we look from the top, you'll see that this is solid. If I shade it. So we want to create a new custom group to give our internal cavities that sparse fill. So we'll go to our Groups menu, create a new group. I'm going to use a template. This icon on the bottom allows us to open up and use other groups as a template. So if I use Part Sparse, by default, it will give me all the parameters that a sparse part has. I can also turn off the contour. Because we're building this inside, we don't need a contour around it. And I can even change the rasters to have double rasters. So now it's more like a sparse double dense. I'm going to accept my group, highlight these curves, add them to that group. Now if I generate toolpaths on this layer, go from the top view, you'll see that it looks like a sparse double dense interior. So I can save this group, Save As, Job. At this point, each group is saved separately, and they each have the custom groups that I would like applied. So now we can bring them together. If we go to the Slice menu, Combine Slice Curve Files, it'll ask me to browse for the other part. I want to grab the Design Rev 1 with internal cavities. I want to open that. Now it brings in this yellow box to show me the boundaries of the part. I want them to overlap, so I can change this point where it brings it in at to the origin once again. This is another reason we have the reference feature. So now they're both at point 000. You can see they'll come in right on top of each other, and I want to use the groups from the slice file. Select OK. Gives me a warning that they're going to overlap. That's OK. Now, if you see, I can zoom in, and those purple curves show my cavities, while the red curves show the part. If I go to a top view, I can actually delete this reference feature at this point, and then I can page up through the part. You'll see at these layers I have both curves. If I generate the toolpaths, I now have a solid part that goes through the tongue or the flange where I need the strength, and I have that sparse fill inside the part. So I can build it without having to support this region at all, but it also uses less material, has less weight, just have a number of advantages that are potentially available.
For further information, contact Stratasys Application Support.